All, welcome to the 64-bit edition of the SecurityTube Linux Assembly Expert course and certification. Now in this video, we will look at loading, storing and moving strings using assembly language. Now primarily, these three instruction sets are very interesting and useful from a string operation perspective. Now each of these have four possibilities. As an example, for load you have loads B to move a byte, loads W to move 2 bytes, loads D to move 4 and loads Q to move 8. Similarly, you have store and move as well, and when we look at the source code, I will explain the differences. So let's jump right in and let's open the file. Now let's begin with the moves instruction. As I mentioned, moves has four possibilities: B, W, D and Q for 1, 2, 4 and 8 bytes. Now moves really moves data from one memory location to the other. So the source is pointed to by the RSI register, while the destination memory location by the RDI register. So here is a super simple example. We clear the direction flag, because if the direction flag is clear, then when we are copying from one location to the other, the addresses are incremented. While if the direction flag is set, then the addresses are decremented. So keep that in mind. The direction flag dictates the direction in which the copy happens. So we're going to clear it so that the addresses are incremented. And at the very bottom, I have a hello world string defined. Here is the length of that string. And in the BSS section, I have a copy variable of size equal to the hello world string and var1, which is basically 8 bytes. Now what this instruction does is first it loads hello world's address into RSI and then copies address into RDI and then calls moves Q. Now moves Q is going to go ahead and copy 8 bytes from the location pointed by RSI to the location pointed by RDI. So let's go ahead and look at how this works. Let's use NASM first to assemble and link it. Now let's load this up into GDB. Set disassembly to Intel, break at start, run, lay out the assembly, lay out the registers, and now let's step through the program. So we clear the direction flag, load the hello world source address into RSI, load the destination address into RDI, and we can look at the destination right now just to see the string in there due to the copy, or rather before the copy. We see there is nothing in there. Let's just do a step I. And now if we look at what has been copied, you would find that 8 bytes hello space WO was copied as expected using the moves Q instruction. Now if you closely look at it, moves Q is really moves, and depending on if you use either B, D or Q, the appropriate pointer type is chosen. So we had used moves q, and hence a keyword pointer is chosen to denote that we are looking at 8 bytes at a time. Fantastic. Now let's look at the second part. Now moves q in isolation is typically not too useful. So the way programmers use this is to run it in a loop and move a large amount of data from one location to the other. And this is typically done using loops, and we are going to use the rep instruction to do it here. So at the next line, we clear the direction flag again. Then we go ahead and load hello world's address into RSI. And the first thing we also want to do now is to go ahead and zero out the copy variable once again, right? So copy actually has hello WO in it right now, which we want to remove. So we are zeroing out RAX and then copying the value of RAX, which is 8 bytes, over hello space WO to again make it 0. And then we load the address of copy into RDI. And after that, we are going to loop. So we would like to loop based on the length of the string. So we load the length into the RCX register, and then we call rep moves B, or rather moves byte, and rep moves B will continue len number of times and move the byte from RSI to RDI to ensure that the entire copy happens. Now let's go ahead and do this. So let's step I. Now this should zero out the position of copy. Let's verify that. As expected, it zeroed it out. Now we are going to go ahead and move the length of the string. And now the repeat operation is about to start. So we can monitor that by creating a hook stop. And just go ahead and print copy as a string so that you can follow how it changes. Let's do a step I. Here is the HELLO space WORLD, and we move out of the rep repeat loop to the next instruction, right? You just go ahead and overwrite hook stop. Now look at the next part. So this is how the moves X instruction works. Now keep in mind that rep, rep-p, rep-ne, etc. are used a lot along with these instructions. For the rest too, I'm going to just illustrate the basic usage, and you can try using rep or other combinations to play with them. Now moves was really a copy from one memory to the other memory location. As far as stores is concerned, again you have B, W, D, and Q, but in this case we actually store from register to memory. So I've loaded up this long value into RAX, and then I'm going to load the destination into RDI, which is var1, just 8 bytes if you remember, we defined in here. And then I'm going to call stores Q to store this value inside var1. So let's see if that works. So I'm going to do a step I again. This has loaded the value 1, 2, 3, 4, rather 0, 1, 2, 3, 4, blah, 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 EF into RAX. I'm going to load the value of var1 into RDI, and now I'm going to copy it. Before that, let me just print the value of var1 before the copy happens. So it's all zeros. Now let's step through it. And now let me again print the value of var1 to prove that the register to memory location copy has happened as we wanted. Fantastic. So you can play with stores once again. Finally, loads, which is again has the options of B, W, D, and Q, is really the reverse, which is copy from memory to register. So all I'm going to do is I'm going to XOR out RAX to 0, and then this time var1 already contains the whole 0, 1, 2, 3 up to EF. So I'm going to load the address of var1 into RSI, and then I'm going to call loads Q to copy var1 into RAX. So let's do that. Let's do a step I, zeros out RAX, loaded the value of var1, and then finally you're going to go ahead and call loads to copy var1 into RAX. And there you go, the copy has happened successfully. Last three steps are really the exits is call and the program exits. Fantastic. So hopefully the functionality and usage of moves, stores, and loads is completely clear to you now from a 64-bit perspective. And if you're enjoying your time here at Pentester Academy, we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you very much and see you in the next video. Bye-bye.